Oh, no TV. Come on. Right, on we go. We'll have a look at question 3 first.
Summer didn't come yesterday.
He did.
Oh, he come?
He did.
Really?
And now he's not here now.
Yesterday they can't, and
Oh, really?
One day, maybe all of us can be in class together. Let's have it up now. Okay, so in number 3, what you have is this. You have a chimney.
always eating
What's a chimney? That's a chimney.
this
That's a chimney.
chimney.
Chimney, yeah. And then what happens is they're 30 centimeters apart. So that's 30 centimeters. Okay?
Oh, it's 30 centimeters.
Yeah.
You go size 30.
What?
Is this?
Between what and what?
Well, you know, maybe, yeah, no, true. But I'm picturing perhaps it's inside of bricks. You know? This is the metal.
Oh, the thickness.
Yeah.
Oh, it's one. No, it's 2 planes. Fine.
Let me draw. And this distance here is 10 meters. And there's some particles of 10 to the minus 5 kilograms, and they rise at a speed of half a meter per second. Some of the smoke is dusty, so they have a charge of 10 to the minus 10. So this is what happens. Some smoke comes up the chimney, and there's dirt in the smoke. And the dirt has a positive charge, and this is positive and this is negative. So what will happen to the smoke? It will hit to the edge. Okay? Now, the smoke will still come out, but some of the dirt will stick to the wall because it is positive and the wall is negative. So it's like a way to clean the smoke, make it a little cleaner, you know. Now, here's the problem. If the smoke starts here, then it must travel all the way over to here. And if the smoke starts here, it's okay. So we want all the smoke, all the dirt. So we imagine the worst situation is if the smoke is all here. So it must slowly move to the right, and then it just about hits at the end. That's like the worst possibility. And the best possibility would be just the smoke hits here and moves up like that. That would be best. Okay, so we need to look at worst. Okay, how quickly is the smoke moving? Is moving up at half a meter per second. So how much time do we have to catch it? How much time do we have to catch it? How much time? Oh, come on. No.
Oh, 5 seconds?
No.
Oh, we need to do this?
No. Yes. Oh, come on. Come on, how much time?
Time. But
It's not 10?
No.
We don't use 10?
No. Well, you use 10. Well, it's not 10. Oh, come on. There's the speed. There's the distance. What's the time?
5.
No. 20.
Huh?
20. 20.
oh,
We're good? Okay, right. So, you have 20 seconds to catch the smoke. So let's say here's some dirt. And we want to go from here over to the right. Okay? we look in the X. The U is 0. The V, we don't know. The A, we don't know. The T, we have 20 seconds. The S, we have 0.3. Now we need to get the A. You know that A equals F over M. That's good, we have the M, but we don't have the F. But you learned that F equals QE. So this is equal to QE over M. We have the Q and the M, we don't have E. But you also know that E equals V over D.
Yeah.
So this is equal to QV over MD. We know the Q. We want the V. We know the M and we know the D.
Is that
Okay.
even thickness?
Yeah. So what formula could we use? S equals, I could say S equals UT plus a half A T squared. Okay? So that's gone. That's 200. So you get 0.3 times MD over Q, that's equal to V. Now I tell you the M is 10 to the minus 5. I tell you the D is 0.3. And I tell you the Q is 10 to the minus 10. I think. Is that right? No. Stop. Yes. Where's my 200 gone? I lost my 200.
Over
200 here.
Yeah.
Yeah, 200 there. Okay, okay, 200 there. Yeah.
Q equals
10 to the minus 10.
and M over
10 to the minus 5.
D.
0.3.
Okay. So 45.
Correct. 45 volts. That was an exam question.
What is the big V?
Volt. Voltage. Yeah?
Is that LTS?
LTS.
Point after
VO LTS.
Oh, okay.
Oh, no.
Man, I'm so hungry.
Hungry.
Do you have lunch?
Yeah.
Yeah.
Terrible.
Why?
I have a Tesco lunch milk
Tesco lunch milk?
for
Ah, they're nice milks. I had pasta for lunch. You know pasta?
pasta.
Like noodles?
Oh yes,
I think noodles are popular in China. Right?
Actually, North. I can eat
No!
noodles.
You don't like
Actually,
noodles?
In North, I think.
enough.
Oh, in North.
I can eat noodles like 4 weeks. 3 meals every day is noodles. It's fine for me, totally fine.
Every meal.
Every meal,
Noodles.
keep for a week.
It's fine. Okay.
Totally fine.
Totally fine. Okay, fine. Fine? Alright, let's continue with the next lesson. Is that a question okay? Yeah. So where is Summer? Did you see him today?
He says before 2:30 p.m.
Yeah.
He say just wait for bus.
Okay. So maybe he's on the bus.
Now I think just come here, but we just one class. I think it's no
You just have one class after lunch?
now. Oh, we just have one.
Yeah, we just
class.
went 1 hour
Oh,
of physics.
After lunch?
yeah.
Or 1 hour today?
Yeah, 1 hour today.
That's it?
No, we had lab chemistry.
Oh, you had labs. Yeah. In the morning.
Oh,
Yeah. How were your labs?
Fun. That's
Yeah.
nutrition. That's really easy one.
We'll do the physics one soon too.
Easy.
Oh, yeah.
Okay. And why we have, tomorrow 11 a.m. we have one
Yeah.
physics class.
Yeah.
Yeah, why just put in today?
Today and tomorrow.
Yeah, because tomorrow there's only one physics class at 10, so we have maybe 2 hour or 3 hour breaks.
Yeah.
And we have EAP in the afternoon, and we have physics today, only 1 hour. Okay.
I don't know why.
Just trying.
Oh, anyways,
Mm,
we'll continue. We'll continue.
you can just watch video.
Ben needs to practice his English.
It's like
And you need to practice your English.
I not only say to, I even say the Korean to Chinese in
Not
Chinese.
English. I corrected your essay,
So
so English.
I see.
Remember your physics essay?
Oh,
I corrected it.
you're correct.
but you say
Oh.
we don't have too much English, just say the facts.
Yeah. It's okay. Your one was a little better. I'm sorry, Ben.
Always,
Her English is a little better.
I know.
So, but you passed, so that's good. It's good.
Good.
Yeah.
Fast.
Yeah. No, that's good. It's good.
Enough.
It's enough. It's fine. Trust me, it's fine. Okay. Electric field potential. You got that? Yeah.
No.
Yeah.
It's EV and NJ.
Don't worry. We'll have a look now. We'll have a look. So, when a particle is above the ground, it has potential energy. You know this. Because of forces acting on it, which causes an acceleration, which would increase the speed and therefore kinetic energy. So the kinetic energy must have come from somewhere. Therefore, it had potential energy at the start. So I just want you to just fully appreciate that. Here is the ground. And we say that this mass here has potential energy. And the reason it has potential energy is because there's a force here of mg. And this force will make it hit the ground with kinetic energy. And so the kinetic energy here must have came from a potential energy here. That's the reason why it has potential energy. Okay. When a charged particle is between two parallel plates, there's a force, just like gravity, attracting the particles to the plate. Therefore, it has the same potential energy. So I'll explain again the comparison. So imagine that this plate here is negative, and this plate here is positive.
I remember if just an electron so small.
Yeah, no, don't worry. I know what you're thinking. Don't worry. No gravity in this picture. Okay? So here we have a small charge, Q, we'll say. Okay? And Q is a positive. So what will happen to Q? Well, there will be a force. Straight down, right? Now what is this force equal to? Is equal to Q E. Because remember you have the formula E equals F over Q. Remember that formula? So
No.
F equals, okay, well, it's true. It's like in the first, yeah, okay. It's like the first formula. Aw, makes me sad when you forget. So, what was I saying? Yeah, so F equals QE. Now, in this first picture here, we said it has potential energy. Potential energy is equal to mgh.
Oh.
Now, if you look at the two pictures, they look pretty much the same. Instead of an M, there's a Q. Okay.
So it's QE.
The M here, yeah, you're getting to the idea. Yes, I think you have it, Ben. Instead of an M here, there's a Q here, like we said. And instead of a G, which is a constant, there's another constant here, E. So that makes me think, well, if this formula is mgh, and let's call this distance here D, as an example, what do you think the formula for this one might be?
QED.
Q, E, D. Right. Pretty nice. So that means, if you have two plates and the particle enters the two plates, it'll have a potential energy. And it will shoot down and hit this plate. And the kinetic energy here equals the potential energy here. So you could even say, as another formula, QED, yeah, go on, Ben, equals a half m. So therefore, QED equals a half m v squared.
Oh.
Yeah, nice. Now I like this picture, so I would like you to draw it in your notes. Yeah?
It's half mv square.
Mm?
Okay.
Don't worry so much about that. This is the important result. I would like you to draw this. I think it's a nice picture. Because it shows you the I would like you to draw this because it's a nice picture. Because it shows you the similarity between the two situations.
Did you see the drone?
The drone?
Drone.
Joan? The teacher Joan?
Yes.
Yeah, I saw her today. Why?
She is very sad.
Why?
No class. No student.
Ah, this morning.
No.
Yes.
2 p.m.
Oh, what was at 2 p.m.?
Just before this class. I come in here. It's no student. Only.
Oh, really?
Oh.
Do you have class on 2?
Ah, I remember. They have extra maths.
But there's not on the timetable
No, it is on the timetable. For
students?
some students.
Oh.
Some students. You see, it's Ramadan. I don't know if that affects things.
Oh yeah, Ramadan.
But I remember yesterday also has some student in the outside just wait for teacher, but no teacher.
That's yeah. What, Summer? Why are you so late?
Sorry. I've been for the past 20 minutes.
Oh, Summer.
Sorry.
I think you've got a attendance problem.
Yeah. I know.
79%, huh?
79%?
That's what he told me.
Yeah.
Oh, so which means I'm better than you.
Yeah.
Because I thought I'm like 80 or something. But it seems like okay. I'm not really to ask if I'm
80's not great either.
I
All right.
did ask.
Continue.
No.
Oh,
QED go
okay, continue. All right, so yeah, we talked about that. Now, oh yeah, so just other things to add here. So we'll just go to the side. So if you like in this picture here, you know that E equals V over D for this problem. So you could also say PE equals Q V over D D. So you get this other formula which is useful, which is QV.
So the volt usually is given?
Yeah. Oh, and maybe you know this from chemistry. These plates have a name. They have names.
Okay.
No, they each have a name. A positive one and a negative one. They each have a name. No, the plates, the metal. I think you know this from chemistry.
Orbital?
Auto?
No, orbital.
No.
I don't understand what place.
This is negative. This whole plate is negative, and this whole plate is positive. These plates have names.
I don't.
What's it called?
This one is called the cathode. Do you not do this word in chemistry, cathode?
I don't.
No. Are you sure? Are you sure? And this one is called the anode.
No. If I came to school, I think that class don't have this. That one.
I don't believe you.
Yeah, why?
Who's your chemistry teacher?
Lauren.
I'll send her a text message and ask her. Are you sure you didn't do these? Are you sure to think cation? 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 Are you sure?
Anyway, we don't study. I don't know.
Anyways, okay, whatever. Right. Now, remember, if the potential energy is positive, the meaning is, we say the charged particle has potential energy. Fine. If it's zero, what does that mean? What do we say? We did this in mechanics. Do you remember? We did this in mechanics. What's the meaning if it's zero?
No H.
Yeah, but what do we call it? Is it something special?
At rest.
I don't know. No, not necessarily at rest.
Mm.
We say it's free.
Yeah.
And then if it's negative,
Under zero?
yeah, but what do we say it is? Yeah, what's it called? Touch.
More
We
free.
say it's trapped.
More free.
No, less free. It's trapped. You forgot this. You see, I know students forget this. That's why I do it again in this lesson. So, positive has potential energy. Zero is free. And negative is trapped. Okay? Do you remember this?
Yeah, I remember the three. Like you mentioned. Is that door inside there have something? The fire door?
What do you mean? Oh,
Is it empty? Or just
I don't know. Usually these doors are empty on the inside.
is there another way to go inside?
I don't know.
'Cause yesterday there's a business student was here
Yeah.
and they were waiting for the door open or something. They were waiting there in there and they heard sounds like the cats inside and they go to call the accommodation security and like when they knock the door and is hears more loudly the sound and when they go to call the
That
security
is from the
guard-
window.
No, it's from the door inside.
Ah, okay.
And when the security coming there's no sound. Nothing inside.
Yeah, maybe the cat got in somehow, yeah. Okay, you got that, Ben? So, the conservation of energy means that the energy at the start equals the energy at the end. And we talked about this already. You know this formula from mechanics, right? So, that gives us the other formula we had earlier. I think you wrote this down. QED equals a half mv squared. Yeah? And you can also say QV equals a half mv squared. I think you wrote this down, didn't you? Yeah? From earlier? Okay, anyways. Now, if you look at this formula, let's say this is positive, this is negative, and this is an electron. This electron has potential energy, right? And what's the formula? It's equal to QV. Yeah? Now, Q is very small. What is it, like 10 to the minus 19 or something. And the V, it's not so small. V is usually like 1 volt or 2 volts or whatever, so it's not small. So it means in total your answer is very small.
Yeah.
Now here's the problem. 10 to the minus 6 is micro, 10 to the minus 9 is nano, but what do we have? 10 to the minus 19, isn't it? That's like, it's too small. So what we do is we use a new unit. Yeah, a new unit of energy. So we use a unit called the electron volt. That is how much energy this guy has if there is 1 volt here. So you can think of it like this. 1 electron volt is equal to E, which is Q, times 1,
Yeah.
which is equal to E,
Yeah.
which is equal to, what's it, 1.6
Oh,
times 10, yeah, O2, times 10 to the minus 19 joules.
Yeah.
So this is energy, but it's very small. It's actually very, very small. And the exact definition is this. 1 electron volt of energy is the energy gained when 1 electron is accelerated by 1 volt. So just like in my picture here. In the exam, you know, they'll want this definition, but I just remember it like this. 1 electron volt is E joules of energy. It's a small amount of energy. Okay?
so if they ask,
Yeah, they want this.
we should remember this or just this formula.
What I do is I remember the formula and then try to put it in my words. So Ben, if you can remember the picture, you have this, this is 1 volt, this is 1 electron, and the energy of the electron is 1 electron volt. Yeah?
True.
Joule, yeah. No, 1 electron volt. Yeah. This is like joules. It's just much smaller. But anyways, you need to write this box down. Go! What are you doing on your phone? What are you doing?
This, my mom and dad was transferred to me some money like for my birthday
When's your birthday?
tomorrow.
Oh, how old will you be?
If you say Chinese age is 21.
But Irish age,
20.
20, yeah.
Xin-
Our age is different from Chinese.
In Ireland, you are born at 0. In China, you are born at 1.
Oh, okay.
At that time in China, it's already like nearly 12 o'clock. So that's why they.
Ah. So you can spend all your birthday money on us tomorrow.
Not really.
You can
That's
bring
too much.
too much. No, that's okay. I don't mind. It's no problem.
But maybe we'll spend like 100, 150 or something. So I want my friends to my apartment at this weekend.
Don't drink too much.
No, we will drink Saturday. So I'm fine.
Good
for
idea.
Monday.
Good idea. Got that? Okay, got that, Ben? Right, here's a small question for you. What's 1 electron volt in joules? I already have this one done. 1 electron volt is 1.6 times 10 to the minus 19 joules. Now, what I want you to do for me is change 1 joule into electron volts. This is for you to do now. You don't want to do it, Ben? What's the answer here? Yep. Correct.
Just 1 over 1.
Yep, correct, yeah. Okay. Right.
Sorry. 1 E volt is equal 1.6.
10 to the minus 19 joules.
Okay.
2 plates are separated by 2 centimeters. 500 volt potential difference. How fast will the electron hit the positive plate? So I'll draw the picture here. What you have a plate here. This plate is negative. This is positive. The voltage here is 500 volts. You have an electron, and it comes down and hits this plate. Oh, and this distance here is 2 centimeters. And my question is, what is the speed here? Now, look, for these questions, I think Ben noticed this before. There's 2 forces here, right?
Yeah.
But the gravity force is not important because the force from the field is so strong. The gravity force is not important. So the way to do this one is to look at the potential energy and to look at the kinetic energy. Now I know the potential energy, you could say, is mgh plus QED, but you don't care about the gravity because it has so little effect, you know. Right, I'll give you a minute. Maybe you can give me the answer. What's the speed here? And it's an electron. Okay, so look, the thing here is you say QV equals a half V squared. So the V is 2QV over M square root. Now look, you know the Q is equal to E. You know the V is equal to 500. And you know the M, it's 9 point, yeah. So, did you get an answer somewhere?
Yeah.
What'd you get?
The V.
Yeah, this.
60.
60? Okay. 16,
Yeah.
not 60.
Yeah.
3.31 times 10 power 16.
Yeah.
Yeah?
Yeah.
Okay, fine. Okay, anyways. Right, one more question here. An electron enters a field which is at a potential difference of 10 kilovolts. The electrons accelerate across the field until there's 3 protons at rest on the positive plates. The electron binds to the protons and they move off. The plates are some distance apart. How far did they move? Okay, I'll just draw this for you. So here's the story here. You've got 2 plates, and here there are 3 protons. This is positive and this is negative. And here is your electron again. Okay. And again, this fires down. But then what happens is it sticks to the protons and they move off. This here is 10,000 volts. Okay. And do we know anything else? No. 3 protons, 1 electron. So first what I do is I say that the potential energy here equals the kinetic energy here. And just like in the last question, I get this formula. V equals root 2QV over, what did we say last time? M. Now just to be clear, that's the mass of the electron. So that is 20,000 E over ME. Is that okay? Is that okay? Now, what happens next? Look, here's your 3 protons, here's your electron. They stick together and move off. So that's this type of problem. M1U1 plus M2U2. So you have ME root 20,000 E over ME plus 0 equals ME plus 3MP times, we'll call it X. X. So the X will be ME root 20,000 E over ME over ME, yeah? Plus 3MP.
In the to 20,000 E,
Yeah.
that E is unit or 1.6?
1.6.
Oh, okay.
Yeah, yeah.
Oh, so
Yeah.
the answer is wrong. I didn't turn the 1.6.
Oh, okay, fine, okay, fine. Yeah, I thought it seemed too big.
Yeah.
So it's more like roughly 3 times 10 to the... Oh, you didn't times the 1.6?
Yeah.
So it'll be like something smaller.
Yeah.
Okay, fine. Thank you.
Minus
No, I think it'll still be... anyways, it doesn't matter. And that's the answer here. Now, I don't have a calculator, but wait, I want to do some tricks. Don't do this in the exam. But just for a rough idea, okay? This is so small compared to this, we can kind of forget about this. And I think the proton is it like 500 times bigger than the electron? Something like this?
1.67 10 minus 27.
Yeah, but how much bigger is it? Like just roughly in chemistry. Anyways, it doesn't matter. What I'm saying is, never mind. Doesn't matter. You can just put it in on your calculator. We won't do that, and we'll just get the answer then. Because you know the mass of the electron, you know E, you know this, you know this, you know this. You want to check it? What's our time?
No.
No.
Yeah, no, we can just. It's you know how to use your calculator, so it's no big deal. Okay. Summer, we were talking about the physics experiments. When would be a good time to do them? Maybe we'll talk about them. Maybe we'll do them next week in class.
Let's save the timetable.
Don't worry, we'll figure it out.
Well, we can do it in for
This Friday?
Yeah, we have to class.
Do experiment Friday?
Yeah. What do you think about?
Good idea.
It's such a. Well, no, before you do the experiment, you're supposed to make the plan for the experiment. So you're supposed to bring in your laptop or your notebook and to make a plan on what you will do.
So how about tomorrow? We have 1 hour class.
Yeah, let's make the plan tomorrow.
Yeah.
So we'll have to do. Well, let me just stop this here. Now, here's my little secret for you.